All right. As I was already introduced, my name is Grant Vergottini. I'm the CEO of Xcential Corporation. I think I went ahead. All right. I'm the CEO of Xcential Corporation. We're based in San Diego, California. I've been in this field for 24 years now. I work with Monica and others with the OASIS standards body on legal dark ML. So we're the group that defines Akoma and Torso. I'll briefly mention it at the end. Oh, going to take a while to get used to this. I'm not a lawyer. I don't have a legal background other than being in this field for 24 years. I'm a software developer. My background is actually electrical engineering. I come from the Boeing company and I come from computer-aided design. That's the area that I know best. I ended up coming into this field quite by accident. The state of California learned of me and they asked me to use my skills to solve a problem for them. I did. I started a company and that's where we are now. We have customers around the world. We've been in this field for quite some time. And there are more customers even in this list, the new ones coming in. So I thought I would start with a Christmas story because I like to tell stories. And I promise this might not seem like this has anything to do with legislation, but in the end, you'll see the connection. I went home for Christmas to the state of Ohio. It's where my mother lives. She lives alone now, and I wanted to be with her. One of the things she likes to do is feed the birds. And so she puts bird feed out, and there are lots and lots of birds all over her yard. And it's quite fun to watch them. She takes pictures, she posts them on Facebook. And then one day, all the birds were gone. There were no birds. It was quiet. What was happening? So I looked and I saw a great big bird sitting on the fence. And clearly all the other birds were frightened. I couldn't make that bird out. So I got my phone out, I took a picture and I zoomed it in, and that's what I saw. And I couldn't tell what that was. It's a bird, clearly, but it was too far away. So I thought this is a great task to give to Microsoft Copilot. So I fed that to Microsoft Copilot. And I said, what is that? And it gave me those 4 birds. It said it's one of those. I told it I was in Northern Ohio and looked it up, and those are the common birds that we would see. But those are little birds. It didn't have enough context to understand what I said. So I gave it more context. I said, no, this is a larger bird, and it appears to be a predator. It's scaring the other birds. So Copilot came back very authoritatively, and it said, that is an eastern screech owl that you're looking at. It's a bigger bird, it's found in Ohio, and it is a predator. Problem solved. But I said, that didn't look like an owl. Does that look like an owl? So I said, takes a while. Please sharpen this image. Please sharpen this image so I can more clearly see what this is. And so it did. And that is the image it gave me. That is an eastern screech owl. Now I looked at that and said, it was right. That's an owl. No, that's not an owl. I wasn't convinced that what it had done was to sharpen the image. I think it had used the information I'd just had, the conversation I just had, to distort the image to look like an owl. Clearly, that's what it did. The little critical thinking part of my brain said, something's wrong. So I went to the feed store where they sell bird feed, and they're experts in the birds, and I showed them this picture. And I said, what is that bird? I don't know the birds of Ohio. To which they answered, it's a Cooper's hawk, obviously. Anyone around here knows it's a Cooper's hawk. So what happened? Why didn't the AI tool know that? So AI tools have an attention span. They use the information that you've shared with them to flavor how they respond back to you. All that information has been gathered. So the conversation I had had that had led it to conclude that it was a owl had been used to then modify the image to confirm that it was in fact an owl. So each answer is based on the context of the conversation that came before that. And if the conversation goes wrong, so does everything that follows. So then the thing I wondered is, now that I've had that conversation, will the AI tool forget what it had just learned from me? So I waited a few days till I figured, okay, enough time's gone by. And I went back to the same tool and I gave it the same picture and I asked the same question. And I said, please sharpen this image. Doesn't look like an owl. It didn't know to make it look like an owl, so it didn't skew the result. So then I asked the question, now I'm in Northern Ohio, what is that bird? It said it's a northern woodpecker, northern flicker. It's got it wrong again. But the interesting thing is it also showed its work this time. It explained to me why it came to that conclusion. And the reason was it had a spotted belly. I can sort of see a spotted belly. It said it had red whisker on the back. That's not in the picture. It said it had brown or gray upper parts. Yeah. Had a white rump. No. So it was still completely getting it wrong. But the important point was that it had remembered, it had forgotten what it had learned from me the time before. And that's important because when I talk about the applications we're building, it's an aspect that we're going to use. So the thing to remember and realize about AI tools is that they work on probabilities. They aren't deterministic. They're looking at things and giving you an answer that is probably right. But it also doesn't know what it doesn't know. If the information isn't there to be discovered, it doesn't know about it. AI tools don't have qualifications. They're not qualified as lawyers, although it is possible, and it has been proven, for ChatGPT has taken the bar exam and passed quite well too. But still, it's not a lawyer and it's not practicing law. AI tools don't always, in my case, it actually did show the work, but it doesn't always show how it arrived at the conclusion. And when it makes mistakes, it doesn't own up to them. What the AI tool should have done in my example is when it sharpened the image, it should have come back and said, upon further consideration, that answer I just gave you was wrong. And now I would conclude differently. Instead, it said, I gave you that answer, so I better make this picture look like what I told you it was. So it went the wrong way. So the thing to realize, AI tools are based on probabilities. As I said, I come from the Boeing company. And what I used to do at Boeing a long time ago was that I worked in the area of failure mode analysis. Failure mode analysis is when you identify all the things that can go wrong with an airplane, figure out what would happen when they go wrong, and make sure if what would happen is that the plane might crash, won't happen. You've got to identify what won't happen. In my case, I was looking at electronic systems, and electronic systems are incredibly complex. Even back then, you could identify 1 billion things that could go wrong with a system. 1 billion things. We had very sophisticated simulators that could simulate 1,000 things going wrong at a time in a day. So if you have 1 billion things that can go wrong and you can simulate 1,000 of them in a day, in 1 million days, you can get through the task. If you do the math, that's about 2,700 years. Clearly, you can't solve the problem with deterministic fault simulation. So we looked instead for probabilistic tools. AI tools are probabilistic tools. We could get the answer much quicker with probabilistic analysis rather than deterministic analysis. Problem was, with probabilistic analysis, you had to accept that there was an error rate, that you couldn't count on the answers being correct. And in our case, the probability that the answers were wrong was too high. You have a system that's going to be in service for half a century. You're going to have thousands of planes flying, maybe half a dozen flights a day. Pretty soon you can calculate 500 million flights. You need to know at very small with a very large degree of certainty that that plane won't crash. So my job as a very young researcher at the Boeing company was to try and find something in the middle. Could we use the two approaches together to make the problem solvable? We couldn't wait 2,700 years, and we couldn't have erroneous answers. That has been the flavor of everything I've done since, trying to use all the tools and technologies that are available to us in a way that we can come up with a solution. And that's what we're doing. So we're building our first two AI applications right now. One of them went into test just yesterday. When I get back, we're going to put it in front of the customer. The other one isn't quite so far along. In the past, we have actually dabbled in natural language processing, but this is the first time we're actually using AI technologies. I can't go into detail how these applications work. They're not announced yet. We will announce them in the coming months. Later on this year, I'll be able to talk about them in more detail. But I will say these are practical applications. They're not science fiction. This is low-hanging fruit. These are applications that are fairly easy to build. They use existing capabilities, and we know we can build them. They are designed for use by the institution. These are not applications that we're going to make available to the public. They're for use within the institution of the government. We service government agencies. They want us to innovate. That's one of the benefits we have as an external company, is that we can innovate in ways they can't. But they also don't want us to go crazy. They don't want us to do stuff that we need to be responsible and understand what their concerns are. So when we build systems, we have to put guardrails in place. We have to make sure that we are constraining the system, guiding the solutions we do. We can't just use the tools running wild. We have to tame them, make them work in a way. And we also can't do stuff that looks like magic. Everything has to be able to be understandable that how it came to that conclusion. There is a Russian proverb, trust but verify, or trust but validate. During the Cold War in the last years of Ronald Reagan's administration, he would often use this expression, trust but verify. This is an approach we have. We're not going to assume that the answers that the AI gives us are correct. As I showed in my example, they're not always correct. So we will double check the results. And we will always validate the answers. If we can't validate the answer, if there's no way to check it, we won't use it. And that's just a principle that we're using. Everything that we do with an AI tool has to, by some way or another, be validatable. In exploring this application, we've been quite surprised by what we can do with ChatGPT. Actually, very surprised by what we can do. There's some surprising capabilities and skills that the tool has learned by having a large language model. Just stuff that it has intrinsically learned how to do by having a large language model. But there are limitations to it. It varies from jurisdiction to jurisdiction. We don't work with one jurisdiction. We work with many jurisdictions. And its knowledge across those jurisdictions is inconsistent. Like, it knows the federal government structures very, very well. Doesn't know California quite so well. Doesn't know Oregon at all. It tends to handle commonly occurring scenarios very, very well. But other things it can't handle very well at all. As mentioned earlier about tables in budget bills. That has always been a challenge to us. All the algorithms we have always struggle with tables in budget bills. It's one of our hardest things. And AI is just as bad at it as we are. There's some key considerations that we have to keep in mind as we build our systems. First is client attorney privilege, having access to authentic data. Does it understand the temporal nature of the law, that laws aren't static, that they are evolving? Does it understand the language, that there are definitions and such? And what qualifications can we expect the system to have to interpret the law? I'm going to talk about each of these. First thing, client attorney privilege. This is turning out to be a big problem for us. We have to preserve client attorney privilege. The information that our tools have access to is not public information. It is highly sensitive. It is information that is used before a bill is even drafted sometimes. So it is information that has been passed around that must not become public. If we're going to share that information with an AI tool, we got to make sure that the AI tool doesn't use it and learn from it. Absolutely sure. They cannot learn anything. Now, we could rely and assume that I talked about the attention span of the system, that it will soon forget what you told it. But that's not a guarantee. And OpenAI have already said, don't assume it. Anything you share with them is subject to becoming public information. You have to assume it. Now, turns out that OpenAI have a subscription service that will protect client attorney privilege, that they will not use anything they learn from you in the learning of the language model. But it comes at a price. The subscription is $250,000 a year. And for a little company like mine, we can't afford that. So we are exploring other ways we can get that sort of level of client attorney privilege. Yeah, I'll get to that. Yeah, that is something because we're doing experimental work right now, we have to pay it. And the customers we're working with aren't willing to sign up for that either. So we're in a bit of a conundrum. We are looking at other service providers that can provide us that capability without us having to pay it. Another option would be to maintain our own LLM, a legislative language model that is way outside of our reach as well. So that's something that we're tackling right now. Turns out getting hold of someone at OpenAI is really hard. Everything is automated there for some reason. So we're struggling a little there. Then it comes to having access to authentic data. The tools we use have to have access. No other way of thinking about it, to authentic data. When it comes to, although we find great capabilities with the public LLMs, there's no history, there's no way to understand where it's getting its information from. Is it current? Where did it get it? What sources? If it's using authentic data, what other data might it be integrating with it? Does it understand that this is an evolving document? How's it handling versions? So again, do we have to support our own LLM? Yeah, probably we can't. But we're finding other ways to handle this. And one is to take advantage of that attention span and to give it we process the data that we want it to use, and then we give it to it and say, perform your skill, what you can do on top of this data and not the data you already have. That way we can assure that we know exactly what data it used. It's not using data that it learned from some other source. Another thing is, does it understand the temporal nature of the law? Does it understand that laws change, that there are effective dates, that there are operational conditions, things that might change what the law is based on other aspects? Does it understand that? Can it understand that? We can't assume that it does. So we process that information before we talk to the LLM, before we talk to the AI tool. And then we have it all pre-processed, and we feed the information to, in this case, ChatGPT, and give it the data that we want without making any assumptions that it has the skills to be able to properly process the complexity of the law. There are other aspects that are tricky. There are definitions in law, and the definitions will define a definition to be applied in these provisions. That definition might be different from the general use of that word. Do we know that the system knows how to handle that definition? Or would it apply the general definition that exists and ignore the definition it finds in the language? This is something that we're still experimenting with, trying to find, is there a way we can say, these are the definitions we want you to apply, forget what you already know, use these definitions. Does that work? And then there are other things. In California law, there are 2 Division 11s by accident in one of the codes. A reference to Division 11 has to be disambiguated. Which one were they talking about? If it gets it wrong, it's going to look at the completely wrong law. Usually there's language that says which one to use. Why they can't fix that, completely different matter. They can't fix it. So there has to be this disambiguation that a human does. Will an AI tool do that right? We can't assume it will, so we do it beforehand. And then the next thing, long ago, I was writing software to process the law for the state of California. And one of the lawyers slapped my wrist and said, you can't do that processing because you don't have a law degree. You've stepped over the line, and now you're practicing law by what you're doing in your software program. And you not only can you not do it, any software you write cannot practice law because you're not a lawyer. The question is, so now you have AI tools that go well beyond what I was trying to do. And they're doing things far more sophisticated. Where's the line? What can an AI system do? What sort of guidance can it provide without stepping over a line when that line today isn't defined? So we're still trying to understand what can we do and what can't we do. I had to rewrite my program last time. I had integrated the information together in one seamless, nice document. I ended up having to pull it apart and present 2 documents and let the lawyer make the associations. I couldn't make that myself because I'm not a lawyer. So this is all stuff that we are experimenting with at this point. Our plans are to turn these into products. We're still figuring it out. We're trying to figure out what the capabilities we already have and the technologies we have, and whether we can, how we can augment those capabilities with AI capabilities to come up with better solutions. We're very aware of client attorney privilege, that this is a very sensitive topic to our customers. It is something that they will not consider if we cannot guarantee it. We have to make sure that we have access to authentic data, and we have to make sure that everything that we present as a result has been validated as best we can. So this is stuff that we're working with customers right now to find the right answers to. I will say that we're exploring a very limited set of AI capabilities just because our customers don't want us to go crazy. But at some point, with what we're doing, we're going to run out of capabilities. We're going to need a more powerful legislative language model. Daniel mentioned the GPO has committed to providing all their information through an API to the AI tools, the public AI tools. We're going to need more than that. We're going to need more than just providing the data. It's going to need to be processable so that the system can actually ask questions. Give me the law as it existed on this date, not just give me the law. Give me provisions, give me parts of the law reliably. And that's going to take a lot more. And for that, we're going to need structured data, structured XML, which is what I specialize in. It's what Monica specializes in. A Komontozo is the standard for doing this. We need to support, we need tools that can understand structured data in a very rich and well-defined way. And that these tools need to be constantly updating because the law is constantly changing. And they need to understand how to manage that change that is happening. And then this isn't there's no single solution to this. Every subnational government, every national government, even international bodies have the same problem. How is this going to be handled? And this is something that we're still exploring. So with that, thank you.